The United States Navy operates 11 nuclear-powered aircraft carrier strike groups, supported by hundreds of ships and tens of thousands of guided munitions. It is the most lethal maritime force on the planet. Yet, when navigating the Strait of Hormuz, all of that open ocean capability is compressed into a narrow channel measuring just 30 miles across. Through this specific corridor flows roughly 20% of global oil consumption and a fifth of the world's liquefied natural gas. The United States desperately wants to ensure this waterway remains open, but its massive military footprint cannot guarantee safe passage. Securing the strait remains an elusive goal because of the specific physical layout of the region. The geography itself acts as a natural counter. Looking at this map of tectonic boundaries, we have to go back 35 million years. The Arabian tectonic plate began pushing relentlessly northward, sliding underneath the Eurasian plate, a geological process known as subduction. As these colossal landmasses ground together, they trapped and buried immense deposits of ancient organic matter over millions of years. Heat and pressure cooked that matter into the Middle East's vast oil and natural gas reserves. At the exact same time, the crushing physical pressure of the collision forced the Earth's crust to buckle and rise. This created towering, jagged rock formations, lifting up the Zagros Mountains and the Musandam Peninsula. While the mountains rose, the immense weight of the collision caused the edge of the Arabian plate to bend downward. This formed a shallow depression that eventually flooded with glacial meltwater, creating the Persian Gulf and the Strait. The deep-time tectonic forces that gifted this region energy wealth also carved out the perilous, inescapable terrain that surrounds it. Looking at this overhead satellite view, you can see how tectonic shifting formed a sharp bottleneck. While the gap is 30 miles wide, the water is too shallow for large vessels near the coastlines. This diagram shows the result. International shipping relies on a traffic separation scheme. Large, fully laden supertankers are physically forced to travel within just two designated shipping lanes, each only 3 kilometers wide. Because of their immense size and weight, these supertankers move at less than 20 miles per hour. Navigating these narrow lanes means they travel along highly predictable routes with zero room to maneuver evasively if attacked. On land, those steep tectonic mountains function as untouchable natural fortresses. They provide radar stations and hidden artillery batteries with a perfect elevated vantage point directly over the water. Scattered throughout the strait are a series of small, rocky islands positioned directly adjacent to the shipping lanes. These outcrops allow an adversary to hide and launch cheap weapons, like swarms of fast attack craft and explosive drones.